Hello, and welcome to the next video in my series on basic statistics. Now, a few things before we get started. Number one, if you're watching this video because you are struggling in a course right now, I want you to stay positive and keep your head up. If you're watching this, it means you've come pretty far in your education up to this point, and you may have just hit a rough patch. So I know with the right amount of hard work, patience, and perseverance, you can get through it. I have faith in you, and so should you. Number two, please feel free to follow me here on YouTube and or on Twitter. That way when I upload a new video, you know about it. And on the topic of the video, if you like it, please give it a thumbs up. That does encourage me to keep making them since I know people are benefiting from them. On the flip side, if you think there is something I can do better, please leave a constructive comment below and I will try to incorporate that into future videos. And finally, just keep in mind that these videos are geared towards individuals who are relatively new to stats. So I'll just be going over the very basic concepts in a slow, deliberate manner because I want you to understand what's going on and I want you to understand why it's going on. So all that being said, let's go ahead and get started. Now this video is a continuation of my previous video on the binomial distribution. In that video, we discussed the very basics of what the binomial distribution is, and we used a couple of examples to get that point across. Now this video is an extension of the problem in that video. In that one, we were looking at the specific probability of a given outcome in the binomial distribution in terms of sales performance for two employees. So we're going to take that problem, extend it a bit, so you can see how this can be applied in other areas or in more complex problems. So let's go ahead and actually look at our example. So this is exactly what we talked about in the previous video. So I'm going to give you the original problem, and then I'm going to change it a bit so you can see how we're doing this concept differently in this video. So you are a sales manager, and of course you analyze the sales records for all your salespersons under your guidance. Now there are two employees you're interested in at this particular moment. Joan has a success rate of 75%, meaning she closes 75% of her sales. Of the call she makes, 75% result in a sale. And she averages about 10 calls per day. Now Margot, on the other hand, has a success rate of 45%, so it's significantly lower, but she averages 16 calls per day. And in the last video, we were interested in what was the probability that each salesperson makes exactly 6 sales on any given day. So we used the binomial distribution to find out the probability of exactly 6 sales. Now I'm going to change that to say, what is the probability that each salesperson makes at least 6 sales on any given day? So we're going to think of 6 sales as our daily quota. And we want to know the probability that each of these two employees, Joan and Margot, makes at least 6 sales on any given day. Now we'll say that later in the video, this example will involve the use of a TI calculator. I'm going to be using a TI-83, but the keys I'm pretty sure are the same on all of them. So if you have a TI calculator available and you want to follow along with that, please pause the video, grab your calculator, come back, restart it, and we'll get going. So I'm going to assume you've done that. We'll go ahead and talk about this problem. So as explained in the previous video, this was Joan's distribution. So along the bottom, we have the number of sales she could make during any given day, all the way from 0 up to 10, because remember, she's making about 10 calls per day. On the left-hand side, we have the probability of each one of those outcomes. So as you can see, the probability of making 0 sales is very, very low. There actually is a little bar there, but it's so small you can't even see it. Then, of course, as we progress through the distribution, once we get to 3, 4, and 5, the probabilities become more, therefore the bars become taller. And you can see they really go up and peak right around 8, and then come back down right around 10. So you can see, at least in this distribution, what is the highest probability outcome. Well, according to this distribution, the highest probability outcome is 8. Okay, so we'll talk about that actually in the next video. But this is her distribution. The bottom is the number of sales she makes in any given day, and the left is the probability. Now, a few things we know. This entire distribution has to add up to 1. So the height of every bar in this distribution, if we added them all together, they would add up to 1. And that's very important for figuring out these types of problems that we're going to do in this video. Now, we've divided the graph into 2 parts. We have the part we're not really interested in itself, and that is her sales below 6. Because remember, we're interested in 6 or more sales. So we divide it into less than 6 and a part that is 6 or greater. So we've sort of split our distribution into 2 parts. We're going to use one part of the distribution to find the other, and that's the key to this sort of problem. So you can see I have the orange bars labeled X less than 6. Those are the sales that are less than 6. In the green, we have X is greater than or equal to 6. So that's 6 through 10, or 6 or higher. So we split our whole distribution of 1 into 2 parts. Now, another way of looking at this is that the orange is still, less than 6, so X is less than 6. But we know that whatever the green is has to be the sort of other half of that. So if the entire distribution is equal to 1, then whatever is in the green part of the distribution will be 1 minus the orange part. You see there? It's like solving a puzzle. So if we can find the orange part, the probabilities in the orange, we can then subtract that from 1 to find the probabilities that are green. And that's what we're going to do in this video. Now, we also know that this is a cumulative probability. And that is that if we start at 0, and then we add 1, and then we add 2 to that, and then we add the probability at 3 to that, we add the probability at 4 to that, at 5 to that sum, and we keep adding the bars together, eventually we will get to 1. So as we progress from left to right, this is a cumulative probability. And again, that property will allow us to solve these problems. So we're going to use a function in the TI calculator that's called binomcdf, binomial cumulative density function. So we're going to talk about how to do that in the next slide. So let's talk about how to solve this in the TI-83 for Joan. So here is her distribution, and again we have it divided into 2 parts. We have 5 or less, and then 6 or more. We are really interested in the 6 or more, the green part. But to find that, we're going to have to find the orange part first. So this is the function in the TI-83, and it requires 3 inputs. N is the number of trials, in this case 10 for Joan. P is the probability of success, which in this case for Joan is 0.75. And then X is the upward limit in our probability we're looking to find. So to find the orange part in our graph, our upward limit will be 5. So how do we get to this function in the calculator? First thing we do is we press the second button and then press vars, and that will get us to the distribution menu. Now once you're in the distribution menu, we can scroll down to the function we're interested in. So the binomcdf, and press enter to select that. And then we'll type in our information. So N is 10, and then we'll place a comma. P is 0.75, comma, and then 5 is the upper limit we're interested in. because again, we're trying to find the orange part of our graph. We'll close that parenthesis and press enter. And when we do, that will give us the cumulative probability that starts at 0 and goes all the way to 5. And that is 0.078. So if we add up all the bars in the orange section of our distribution, they will add up to 0.078. And that should make sense. Look at the bar at 5. Well, right there, it's a little bit more than 0.05. Then the height of the bar for 4. Well, that's probably, 0.01 or so. And then we add that to the bar for 5. So you can see if we add those together, it should make sort of common sense that that'll be around 0.078. So if we got some crazy number like 0.95, we would know that's not right just based on our intuition, because that would mean 95% of the distribution. So again, sort of use your common sense to know whether your answer is right or not, or maybe you keyed something in wrong because it does not make sense. So this is good, 0.078. So we'll put that there where the orange is. So now we need to find the green part. So how are we going to do that? Well, remember that everything adds up to 1. So we're looking for that green part, and that will give us the cumulative probability starting at 6 and going all the way up to 10. So to find the green part, we just subtract the orange from 1. So when we do that, we have 1 minus 0.078, which is 0.922. So the probability of Joan making 6 or more sales in any given day is 0.922. And that's pretty impressive. That's over 92% probability or likelihood that she will make her quota, which remember is 6 or more sales. Now let's look at Margot. We'll do the same process for Margot. We'll go ahead and do the binomcdf function in the TI-83 calculator. So in that case, n is 16 because she makes 16 calls per day. The probability of success is 0.45. And we're interested in the orange part of the graph, which is up to and including 5. So 16, 0.45, and 5. And that gives us a cumulative probability of 0.198. So that goes there. Now we're looking for the green part, so we just subtract that from 1. So we have the probability going from 0 to 5, and then we subtract that from 1, and we have 0.802. And that goes there. So the probability that Margot meets her quota of making 6 calls or more in any given day is 0.802. So you can see in these problems, all we've done is we've figured out the first part of the cumulative distribution up to an upper limit, and then we've subtracted that from the overall probability of 1 to find the upper part. That's all we did. And we also briefly went over the function in a TI-83 calculator that does that for us. So, what is the probability of at least 6 daily sales for each person? Well, here's Joan's graph, and here's Margot's distribution. So we can sum up the probabilities that are all 6 or greater. Or we can do the reverse. Remember, we found out the probability, the cumulative probability up to and including 5, and then subtracted that from 1, and that gives us the green part. But either way, for Joan, that probability is 0.922, and for Margot, it was 0.802. So, therefore, if the daily sales quota is 6 sales, Joan has a much better chance of meeting that quota, even if it appears she is doing, quote, less work. So Joan is making fewer calls per day, but her success rate is much higher. Margot is making many more calls during a day, but her success rate is lower. So it's not, it's not the amount of calls, in this case, not the amount of calls you make necessarily. It is a combination of that and your success rate. So what's our conclusion here? So even though Joan has a lower call rate in terms of making fewer calls per day, her greater probability of making a sale overcomes that lower call volume. So therefore, the greater probability of making 6 or more sales per day, of making that quota, belongs to Joan, even though Margot makes more calls than Joan. So the lesson here is that the probability of any given outcome, or range of outcomes in this case, is a combination of both the number of trials and the success rate. So it's a combination of both of those things. Now I do have some bonus questions for you. So here are the bonus questions. Assuming Margot's success rate remained at 45%, approximately how many calls would she need to make to match Joan's performance? So we're going to keep Margot's success rate at 45%. The first question you have to ask yourself is, does she need to make more calls or make fewer calls to meet Joan's success? Well, hopefully you realize that it is more calls. So because of her lower success rate, she's going to have to make more calls in order to match Joan's performance. Here's question 2. Now let's flip it. Assume Margot's call volume remains 16 calls. To what level would she need to raise her success rate to match Joan's performance? So in question 1, we are keeping Margot's success rate constant, and then we're looking for how many calls she would need to make to match Joan's success. In question 2, we're keeping her number of calls constant, and then we're asking what success rate would she need to match Joan's performance. So if you want, go ahead and pause the video here and actually try to figure that out. Try to guess what you think that's going to be. Because there really is no, precise way, at least at this point, of figuring that out. You're going to have to sort of estimate what it would be. So I'm going to assume you've paused it if you want to try to figure it out on your own. But I'm going to go ahead and advance the slide and you can see what this turned out to be. Well, if we kept Margot's success rate at 45%, she would need to make approximately 19 calls per day, up from 16 to match Joan's performance. So if her success rate stayed the same, she would need to increase her call volume to 19, up from 16. Now the second case, if she kept her call volume at 16, she would need to raise her success rate to at least 52%, up from 45%. So you can see that if we keep one variable constant, we can change the other to match Joan's performance. So in the top one, we go from 16 calls up to 19, or in the bottom one, we keep the calls constant, but we go up from 45% success to 42%. So you can, this is very, once you do a couple of these, they're actually quite easy, but they can be very, very helpful in determining what you need to do in your business or what you need to do in your schoolwork or whatever it might be. You can actually use these binomial distributions to compare any sort of outcome that follows the binomial experiment. Remember, that's a certain n number of trials. The probabilities have to remain constant from trial to trial. The outcomes are mutually exclusive. So P and Q are mutually exclusive, and of course they have to be independent. So any sort of process that works that way can be modeled using our binomial distribution. Okay, so that wraps up another video on the binomial distribution. And again, we looked at sales quota performance. We compared two employees who had different call volumes and different success rates to see which one was more likely to meet our daily quota. And then we talked about what one employee would need to do in order to match the performance of the first employee just by changing a few numbers in our distribution. So again, just keep in mind, I want you to stay positive. If you're having problems in a class, keep your chin up. I know you can do it. You need to have faith in yourself that you can do it. If you're bettering yourself through education, that's what really matters. So hopefully this video helped, other people's videos have helped, and you can get more from your classwork. And remember, please follow me here on YouTube and or on Twitter. That way when I upload a video, you know about it. If you like the video, give it a thumbs up. If you think there's something I can do better, leave a comment below, and I will try to incorporate that into future videos. But most important of all, I want you to have fun in your studies, and I thank you very much for watching, and I look forward to seeing you again next time.